And Mark, if you would, while you're getting your presentation up there, would you just introduce yourself and give us the setup, what you're going to be talking about today?
Sure. Well, you just had a great queue-up question, because that's what we're going to talk about today is SD-WAN. The talk is, goes a little bit beyond just deployment of SD-WAN, but and you guys talked about what are the drivers. So we're going to talk a little bit about the drivers of SD-WAN. But let me first just do a quick introduction for Apcela, because I'm sure most folks haven't heard of Apcela. This is our first time working with you guys at Packet Pushers. We're excited to be here. Apcela broadly is I would say a combination of a managed services provider and managed SD-WAN. We're doing a lot more than that, really around how do you automate AI ops for networking, and how do you really use SD-WAN to create a programmable network infrastructure, not just an automated deployment. And so that'll really be some of the topics we talk about today.
Okay. You said a lot of buzzwords there, so expect to get some questions about that coming in.
Good deal. Well, and great point, because I'd love to have this interactive. So as you guys get questions, let's bring them up. If you guys have points or counterpoints, let's put those on the table as well. What we're going to talk about today, first off, why SD-WAN? What are the top drivers? What's pushing SD-WAN adoption? And of course, behind any adoption is a return on investment. So what are the top drivers? Where are people looking to find ROI, and where are they finding it? What we're going to see is that there's sort of a day one use case, and then there are day two use cases. And I'm going to talk a little bit about some of those day two use cases, because those are some of the things that tend to get overlooked a little bit in terms of ROI opportunity. And so we'll talk about 3 steps to boost SD-WAN ROI. We're going to talk about mapping your applications and your users, and figuring out how you leverage software-defined WAN to deploy distributed communication hubs and ultimately leverage the application-aware routing and automation capabilities of many of the SD-WAN platforms that are out there. And then we'll close with some future considerations to think about for WAN evolution. How do we really move towards more network automation and orchestration?
Sounds good. Yeah.
So the underpinning here is that legacy WAN architectures are starting to break down, right? For years and years, we had a centralized data center environment. We had MPLS networks that brought our users back to that environment. And as applications and workloads have started to move out into the cloud, and of course that's happening now at an accelerating pace, application performance starts to become a challenge, right? I've got this hybrid IT environment where I am spanning my legacy data center environment, and now I'm spanning multiple cloud environments. Some as infrastructure as a service, some as software as a service. I may know exactly where my apps are. I may not know where all of my apps are. And all of those things lead to a lot of challenges around application performance. And I think that's the large umbrella that we're seeing. Underneath that, what are really the top drivers of SD-WAN? And looking to Gartner here, they've done a number of surveys, and there really are a bunch of use cases that drive folks towards SD-WAN. Moving applications to public cloud. SD-WAN is a great technology for split tunneling if I want to try and open up internet access at my local branch or edge locations, and so people look at that. Hybrid WAN has been a movement for at least half a decade, if not more, and that's really been about how do I reduce costs on MPLS? How do I expand bandwidth without taking the cost per megabit of MPLS all the way up the scale? And so SD-WAN becomes a powerful tool for helping me manage that hybrid WAN environment. And that lays into the, how do I reduce my traditional WAN costs, right? We do see today, and shockingly, right, and I'm going to say still, 90% of the large enterprise networks that we're dealing with are highly embedded MPLS networks. But we have seen large scale, multi-billion-dollar companies jump off of MPLS entirely and go to local internet-based services to companies that really need to put a big cut into WAN costs, and they've seen savings of upwards of 40%. There's some risks around that. Another big use case, configuration and deployment automation, and that's really when I talk about day one automation. That's really what we're talking about: the ability to deploy, the efficiency with which you can deploy SD-WAN, right? Compared to programming edge routers traditionally, the ability to deploy a single orchestrated platform where the policies are pushed down, the manpower, person power required to deploy that's that is much more manageable. Supporting video and other real-time applications. I think we've seen, just in the last 2 years, we've seen kind of a big push around broadly cloud office suites, very specifically Microsoft Office 365 and the services underpinning there. Originally Skype for Business Online, now all moving to Microsoft Teams, and some of the real-time video broadcasting services. And so again, people using SD-WAN to try and manage better performance, particularly in a hybrid WAN environment, around those types of services. And then, somebody mentioned on your last question, some very big retail deployments, and I think that's a great use case for SD-WAN, where you've got limited availability of on-site IT personnel. The SD-WAN devices are sort of very low touch. We tend to hear the term zero touch provisioning, and I think technically they are, but there's there can be a lot of issues with that, because you got to have an open path to a DHCP. And so if you're running behind an MPLS, you can have some problems with zero touch provisioning. But very broadly, these are some of the big reasons why people are looking to SD-WAN. And ultimately, SD-WAN, our opinion, is the foundation for low-cost, cloud-ready WAN. As the functions, the workloads move outside of the corporate network, you've got to find a way to interface more effectively with the public internet and the public cloud.
Yeah, in other words, your point is, as more and more workloads get outside the data center, SD-WAN becomes the thing you have to optimize connectivity to those compute functions that are now very far away from you, latency-wise.
Yeah, I mean, you really need access to the internet, right, to get to those cloud applications, and SD-WAN is a powerful tool to help manage that with some combination of security, right? I have a lot of flexibility in terms of how I deal with security around SD-WAN, and I'll talk a little bit about that as we go through. Some of the top drivers of SD-WAN ROI, and again, this is another Gartner statement, and the report I was reading this off of talked about inquiries with over 1,100 clients, and out of those inquiries, over 90% of those users were seeking to deploy SD-WAN to save them money, right? That was a big driver. But as you look at kind of the areas that actually drive ROI, those aren't necessarily the biggest, and one of the ones in particular that is large is application troubleshooting improvement, right? So these are the areas. I think when we think about SD-WAN, we can find savings in the equipment itself. I'm due for an edge refresh. That tends to be a big driver of SD-WAN deployments. And so I'm going to look at SD-WAN for that, and I'm going to calculate my ROI based on the direct savings associated with maybe lower hardware and software costs, but also certainly I'm going to build in the logistics cost of actually doing the deployment. And that's where I think SD-WAN really starts to drive day one ROI. But some of the overlooked opportunities, the biggest one being the ability to leverage the analytics capabilities, the new sets of data that we can get out of SD-WAN that we maybe haven't been able to traditionally get out of our edge routing environments, to improve availability and specifically MTTR. When there is a problem, how do I find that problem more quickly, and how do I do it with less person power?
So you're saying application troubleshooting there, Mark. So in other words, because SD-WAN is doing things like gathering metrics about links, and it can route one application over one link and a different application over a different link based on the policy you've set up, now you've got insights into how a specific application is behaving over the link. And when it's not performing well, you've got data built around that to understand what's broken and how to address it?
Absolutely. There's actually two things in there, right? As you know, SD-WAN helps us manage the disparate performance across two different links. So if I have one link that's starting to degrade, I can manage the SD-WAN environment will manage that degradation for me and shift traffic to the better link. And that's kind of a real-time trouble resolution. But also SD-WAN gives us a lot more data, right? Things like latency, packet loss, jitter. We can get inside and see the applications that are flowing and the volume of those applications that are flowing across each link. And so there's just a much more robust data environment. And ultimately, the real opportunity is to take that data and integrate it with other data sets from perhaps our security environment or our underlay networks. And when we start to integrate the data sets, we start to get out of swivel chair management, and we can actually get into a place where we can see all of the data in a single platform, and we can start to get to the problem much more quickly.
I think another issue is that with a lot of SD-WAN, you get that application identification capability. And so if someone's just saying the network is slow, that doesn't really give you a lot to work with. You can go into the system and see which applications might be being affected, and then apply that to your troubleshooting as well.
Right, and imagine if you could take your traditional routing environment and take the data from that and combine it with an application for more performance monitoring tool like AppDynamics. And if you could put those two data sets together, you could really start to see, hey, is the problem really the application or is it the network? As we all know, the network is first blamed, guilty until proven innocent. And so some of these capabilities allow us to get beyond that. And then reducing network upgrade risk, that gets into segmentation, the ability to segment the network at a much greater degree. So this is all great, but how do we actually get at an environment that allows us to tackle some of these, higher day two, what we call day two automation or day two ROI opportunities? And this, we're going to talk a little bit, and I know this is a design clinic, we're going to talk more about the architectural design that lets you get there than sort of the bits and bytes. But we talk about 3 steps to boost SD-WAN ROI, and it's really about building a cloud-optimized WAN architecture. So SD-WAN, for example, if I go to split tunneling on SD-WAN and I open up a local internet access connection, I still have a security issue. Am I going to open that up to the public internet? Am I going to have a set of trusted applications? For example, I can whitelist Office 365, and so I can certainly let that traffic out locally. But the reality is, at my local branch is not where the internet peering with the public cloud occurs. It tends to be in carrier-neutral commercial data centers. And so we espouse this architecture that leverages these carrier-neutral commercial data centers, what we call communication hubs, building high-performance core, interconnecting those hubs, anywhere from 2 to 10 or more, and then interfacing. And this becomes sort of the middle mile between the legacy enterprise IT environment, the data center environment, and the edge infrastructure, and the cloud. And if you kind of think about this as a broad architecture, it's an architecture that really is optimized for interconnecting with the cloud. And so we talk about starting out by mapping your applications. And this is where a lot of enterprises, particularly with Microsoft Office, start to struggle. And we've seen, this map is a very simple map. It could be an example of an MPLS deployment, or it could even be an example of an SD-WAN deployment. In the case of MPLS, the triangles are the edge locations coming back to centralized data centers, in this case an enterprise with an East Coast and a West Coast data center. To the extent the enterprise is global, you can replicate this by region. And obviously, very typically the MPLS networks will bring everyone back to the data center to a centralized DMZ, and that's where the internet egress occurs. But oftentimes, because of the anchor of that security DMZ, even once the SD-WAN is deployed, and we're using split tunneling, we're using the MPLS network perhaps for our voice and video applications, and we're using the internet link for other applications, but we're still using the encryption capability or the VPN capability of the SD-WAN platform to bring that traffic back to our data center before we go out and egress. And you can kind of see the impact of that, particularly in this environment where an enterprise has an East Coast and a West Coast data center. Those in the middle of the country are going all the way back to the data center before they can get out to the public internet. And if the application, the cloud application they're trying to get to is just down the street, they're covering a lot of ground that they don't necessarily need to cover. In the case of Microsoft, Microsoft has over 120 global peering points. And an enterprise that has 2 data centers per region is going to be essentially peering with Microsoft in 6 places globally. So that's a massive sort of underutilization of the opportunity to improve application performance relative to that particular application. So once I understand where my applications are and my users are, I can leverage these, again, what we call communication hubs. These tend to be built in co-location data centers, very robust marketplaces. They help us manage costs because there are lots of options for network connectivity. These are the places where the cloud peering actually occurs, right? The cloud peering doesn't occur on our broadband networks; it occurs at some head end on that broadband network, and so that's essentially what we want to set ourselves up to, is peer as close to those peering points as possible. And this is probably the most technical side for your audience. I realize this presentation isn't super technical, but what does one of these communication hubs actually look like inside? And so again, you can think about a co-location data center, a rack of equipment. At the base, there's a routing and switching fabric. We have our basically physical routers and switches, typically a physical firewall, and then a hyperconverged infrastructure stack that we can use to virtualize some of the higher level application services functions. And it allows us to take the kind of things that we need to distribute applications between in the hybrid world, between the legacy data center and the cloud, and we can virtualize those services into one of these communication hubs. And you see here 3 different models. Hardware-based model, obviously we can go out and ship hyperconverged infrastructure and rack and stack it. But in a lot of cases, we can actually go out and we can deploy these virtualized services into public infrastructure as a service. And so if we have a regional or a larger hyperscale infrastructure as a service platform, we can take some of those functions and actually virtualize them in that kind of environment. And all the way on the right-hand side, we see we can actually do this fully virtually. We can take all of these services and ultimately run them in infrastructure as a service. And that really gets to the core throughputs. As we're running large backbones, for us it's hard to get all the way to that right side. When we get above 10 gig of capacity, we're still finding that ASIC chips are much more effective. But as we get below 10 gig, we can actually virtualize the entire stack. And so once I have these communication hubs, now rather than forcing all of my traffic back to my data centers, I have an environment where I can, in a secure environment, distribute that traffic much more effectively and more directly to my applications. And so by correctly positioning the the communication hubs, we can open up the right kind of internet peering. And here you would see, here you see, a lot of communication hubs. This could simply be moving from 2 data centers to 2 or 4 communication hubs in a region, and that's going to drastically open up your application performance. And so the third step is to really get into the software-defined WAN, the advanced capabilities. And I think, again, one of the things that's often overlooked is the fact that these things are very programmable environments, right? Our old edge routing infrastructure didn't come with RESTful APIs. It didn't come with centralized orchestration, and it didn't come with deep packet inspection. And so the deep packet inspection capabilities of the SD-WAN platforms allow us to get into application-aware routing. So I can be looking at the edge and saying, okay, this traffic is Microsoft Office. I'm going to send that. Not only am I going to whitelist that traffic through my software-defined WAN environment, but I'm going to route that to the nearest Microsoft CDN environment. As I talked about earlier, 120 peering locations globally. I want to use that application-aware routing capability to route that traffic directly to Microsoft. And then there may be other traffic that I want to route to a DMZ in my data center, and I may build a mini DMZ in my communication hub, and there might be another set of applications or users that I want to use or send through that kind of environment. The other thing that it allows us to do is, I talked briefly earlier about the analytics capabilities of SD-WAN, and so we can take those analytics beyond just the API and put those into an analytics platform and combine that with analytics from other application services components. So I can take my firewall data, the log data from my firewalls. I can take data from my ITSM environment, think SolarWinds, or if I'm using more advanced network performance monitoring tools, like a Dynatrace, or application performance management tools like an AppDynamics. I can take all of those data streams outside of the traditional UI reporting environment and put those into data platform like a Splunk or an Elastic, and start to look at those data sets in a correlated environment. And this is where we really start to get to accelerating mean time to repair, because if I can see all of the data in a correlated environment, I can start to get at the underlying problems much faster.
Does this end up meaning you don't just have networking people looking at this stuff, you're actually sharing this data set with other groups to get to that MTTR?
Yeah, I think in the swivel chair environment, give you kind of a real example, right? Very large retailer, thousands of locations running on SD-WAN, just a handful of DMZs, 4 DMZs in North America, and so all of that SD-WAN traffic gets forced back, into those environments, and there's a problem, right? And that problem is at the DMZ, and so because it's at the DMZ, we think, hey, maybe that problem is a firewall problem. And so we start to troubleshoot the firewall. So the team that's responsible for firewalls looking at firewall logs, and we find, well, there's, we can't find a problem in the firewall, right? Well, maybe it's in the MPLS network that feeds into the firewall, right? And so you end up with different teams or different people looking into different platforms to find the problem, and if it's an application, if it's instantiating itself as an application performance problem, you may have application teams involved as well. And so this gives you an ability to centralize data and share it with all of those teams. But most importantly, you can have somebody who's responsible for looking through and understanding where the ultimate which piece of the stack is causing the problem. And it's very difficult to do that. It just takes time. And so what this does is helps us collapse the time to problem isolation, and that really kind of tees up the opportunity for automation. I think the last piece of the power of SD-WAN is the programmable capability that it brings to the table. Because we have RESTful APIs, not only can we take data out of the API, but we can put data back in. And so here you see again kind of a reference diagram of the ability to take a bunch of southbound APIs, exactly what I was talking about. And so the SD-WAN would be one of these APIs. We can take this data out and we can put it into a data environment, and we can observe that environment, and ultimately we start to find correlations, right? In the example I gave before, if the actual problem is not in the firewall, but it's in an egress router, for example, we have that problem signature, and so the next time that happens, we actually have a data signature for what that problem looks like, and we can find it faster. And it really, again, it's the ability to take the data sets from multiple components of the application services stack and pull those together in a single environment. And of course, once I can start to draw these correlations around problem resolution, I can ultimately start to program those resolutions. So perhaps the problem was a firmware upgrade in the egress router, and if I've seen that problem before, I can actually program that to automatically roll that firmware back. Now we're starting to talk sort of looking out at the horizon, because there's not many firms that are doing this today, but this is really where the future, what the future holds, and SD-WAN is really a powerful component of making that happen.
And with this API set, are you connecting to the SD-WAN controller or to individual SD-WAN edge devices? Yeah,
so you'd be interfacing typically with the orchestrator's API, and so again, as you guys know, there are probably 40-some SD-WAN vendors out there in the market, right? But Ethan, you mentioned that handful on the last AMA question. All of those 4 vendors and a handful more, all run their orchestrators with a RESTful API. And so the ability to sort of extract data out from that orchestrator and push commands back in exists on a fairly broad scale. I don't want to say all 40 vendors in the market have that capability, but that's really what we're talking about. And so if we were to talk sort of specific vendors, it's the ability to take a data feed from a vManage API and integrate that with a Palo Alto Panorama API, put that data together with perhaps a synthetic monitoring tool that's looking, through my underlay network and into the cloud, and then pulling SNMP data from a SolarWinds and putting all of that data into an elastic platform, right? And now I can start to, and even at a rudimentary level, I don't have to have sort of super advanced analytics capabilities. At a very rudimentary level, I can start to visualize the data, right, across those platforms. And so I can even if I'm not that sophisticated, visualization helps me find those correlations much, much faster.
So you're saying you can pull data from a variety of sources, bring it into one place, munge it, visualize it, and then I get a broader perspective that I'm looking at the SD-WAN orchestrator data, I'm looking at router data, I'm looking at firewall data to help enrich whatever I'm doing troubleshooting or analysis.
Yeah, and I think that's the first use case is troubleshooting and analysis, because you're going to do that already today. You're just not going to pull it into a single platform. You're going to log into, that's why we call it swivel chair management, right? You're going to log into 4 or 5 different UIs trying to find the problem, which is why problems turn into hours for root cause. In some cases, days, right? But typically hours, and we can pull hours down to minutes and hours, not hours and days. And so that's really, I think that's the first piece, and that's why you saw that. If we go back to that earlier slide, the ROI around trouble isolation, trouble resolution was actually the biggest one that Gartner recognized in terms of ROI potential, because of the amount of person power that's spent. Most of our time, quite honestly, is spent trying to find problems, right? Something's broken. How many conference calls do people have to cancel because there's a service issue, right? There's an incident, or we're working on something. It consumes an amazing amount of time from the network ops and the network engineering teams to find these problems. But that's a very that's a very base level. And once you find these correlations, you can begin to carry them forward and program, very simple algorithms. If I see this signature, do that, right? Because I've done that, I've done all of this stuff manually. I've done it with teams. Now I simply start to program it and make it all go a little bit faster.
So, Mark, some people might be looking at this product and going, okay, it's kind of like Splunk. Splunk has an apps ecosystem built around it. I can bring in all kinds of data from my boxes and then do things with it using Splunk. Is this similar, different? How would you differentiate?
Yeah, so I'm not actually talking about quote unquote our product, right? I'm talking about an approach, and that approach would be similar whether you're using Splunk, Elastic, or one of 2 or 3 other sort of data visualization tools. We happen to use Elastic, and so in our managed services environment, that's what we use to do this. There's no super special magic here. Anybody can go out and build these environments, right? And I think that's the point here, is that SD-WAN enables it, but most people, this is the overlooked piece, right? People are thinking, hey, I'm going to get the automation around configuration and deployment, and that makes my use case, that makes my ROI, that makes my business case. Everything is good. But if you really want to boost the ROI of this tool that you've already paid for, these are the ways that you start to do that, right? And it goes beyond just how do I reduce my circuit costs, right? Because if you go and look at any network operations organization and look at what's paid for in terms of circuits and what's paid for in terms of salaries, if I could repurpose those salaries to do higher and better things, my ROI goes way up. And the salaries are typically right up there with the cost of the circuits, if not a multiple of the cost of circuits, depending on the size of the organization. You talked about us and our products. Our product is AppHUB, and it's an AIOps platform that's designed to take the RESTful APIs from the services, from the network up to the switching, the routing, security, load balancing, WAN up, and up to application performance monitoring and management, and integrate those at an orchestration level. The market has done a great job of building infrastructure as a service tools for the cloud production environments, but the delivery environment is still very much a manual environment. We're in the early innings of network function virtualization, and how to, and I think a lot of people are puzzled with how do I actually use virtualized network functions. Well, one of the ways you can do it is go out and build yourself some communication hubs, put some minimal compute resources in there, and you can start to distribute some of those application services beyond just the 4 walls of your data center. And for us, this is our global platform, reaches 185 markets in 41 countries. the idea here as you move to the cloud is that you've got to get your WAN to match up with the cloud. The production environment is no longer just your data center. It can be literally dozens of data centers that are physical somewhere in the cloud, and trying to understand where your application workloads are actually operating relative to where your users are is typically the root of your application performance challenges, and very often the root of your application troubleshooting.
It's not enough to just say, oh, it's in the cloud. You actually, as an IT professional, need to understand what that means. Like, well, where physically is it? What's the latency? How far away is it? How do I optimize that flow?
Exactly. The cloud is physical somewhere, everywhere, right? The cloud is a concept, but every workload runs on a machine somewhere, and your user's proximity to that machine is what's going to drive application performance. And again, I think we've seen, I want to say in order of magnitude. I mean, this application performance challenge has been growing as enterprises start to run behind cloud-first initiatives. But it really is Office 365 that's become kind of the cataclysmic event for application performance challenges. And it's really not Exchange that's the big problem, because email isn't a highly time sensitive application. It's when people move to to the file sharing OneDrive, or they move SharePoint from on-prem to the cloud, and some of those that have done it earlier, Microsoft is just kind of getting to geodiversity. So really understanding where your applications run within the Microsoft environment, and how you peer with the Microsoft environment. Again, Microsoft's got a very powerful global peering footprint, but if you don't leverage it, if you're going to force everyone through 4 or 6 or 8 doors globally, you are going to have performance problems. And so that's the opportunity, is to sort of use these tools, the SD-WAN, understand where your users are, understand where your applications are, use tools like communication hubs to create a middle mile, a middle point, an inter-exchange point. Companies like Equinix make this very easy. Equinix sells a product called Network Performance Hubs, and within a lot of Equinix co-location centers, you can get access to a cloud exchange. And so if you put some of those into your WAN, you will sort of multiply the opportunities to get sort of out of your private environment and into the cloud.
Mark, I'm new to Apcela. I have not heard of you guys or worked with your product yet. If you could, what is the problem I have that I'm solving when I call Apcela? Or I have this problem I need to solve, and so I'm going to give you guys a call. What is that problem?
Yeah, sure. Well, so Office 365 performance is one of them, right? I've moved to Office 365, and I'm seeing performance issues, and those tend to be, again, I think our client set. We came out of the capital markets. It's one of the reasons we're fairly new to enterprise. We started out building very high performance networks for securities trading in the high frequency trading space. So we built a very global, low latency platform for high frequency trading, which is a micro market. It's a very exciting market, but it's very small. But what we found is the way that we built those very high performance networks on the backs of co-location data centers with very high performance wavelength services interconnecting those data centers was very ripe for tackling this cloud application performance challenge. And so as we came into this market, a lot of it started around cost, right? And that's been the big driver of hybrid WAN adoption for the last 10 years or so. Let me figure out how I can put more internet into my diet to reduce my MPLS costs. And again, one of the ways you do that is to leverage these communication hubs, right? Because that's where the market is. So rather than bringing everyone to my data center, I go into the market and I'm able to reduce costs. So that's kind of a key use case for us. Is, hey, I want to reduce my cost, but the real driver is application performance. And so and it tends to be enterprises that are legacy, not cloud native, right? They didn't start out in the cloud. They started out, it was zero cloud. And they're moving towards cloud, and some of them are moving faster than others. We have 100-year-old clients that have moved, greater than 60 or 70% of their workloads to cloud, and have a goal to get close to 100. Now, I don't think anyone believes you can actually ever truly get to 100, because there's some mainframe app. There's just a lot of legacy infrastructure that's a lot of work to repurpose that for cloud. And so it's those kind of customers that are trying to, they've moved a front end into the cloud, but the back end is still in their data center. and so now I've got front end and back end performance issues. Or I'm trying to become more cloud native, right? A lot of contact centers moving to cloud-based contact centers, right? Moving from a premise-based Avaya switch to an in-contact, let's say, now NICE, I think, card in contact, and the intelligence for my contact center is in Salesforce. And now I need an in contact to talk directly to Salesforce in the cloud, and I don't really want to rely on the public internet to make that connection. So how do I architect my WAN, right, to deal with those new kinds of applications?
So is the idea then, instead of just doing like a plain vanilla internet breakout and having traffic right across best effort broadband, I can go to one of your communication hubs and maybe get better performance into a cloud application?
Yeah, not only that, it tends to be more of a security thing, right? Because most enterprises aren't ready to just open up internet at the branch, right?
Sure.
Again, for a trusted application, there's a set of applications that they're willing to whitelist, and then there's a set of applications that they're willing to give sort of light security treatment to, and then there's your basic internet traffic, which has to go through a full security stack. And of course, the SD-WAN again gives us the power to choose, right? Based on this user and this application, give me this security treatment, right? Let this traffic out directly to Microsoft. Send this traffic to a local secure web gateway. Send this traffic and this user, but only because it's this user, send them through the centralized DMZ back in the data center. And again, that's one of the oft overlooked capabilities of software-defined WAN, because it has that deep packet inspection. Again, I'm not speaking to all SD-WAN platforms. I'm certainly speaking to all the ones we use. Have that sort of deep packet inspection capability so that you can take advantage of that application-aware routing.
Is there a WAN optimization aspect to this? And in that context, I mean like old school Riverbed, let's say, they would do protocol acceleration. Yeah.
Yeah, well, I think so. And this is Mark's opinion, not necessarily the market, but as we get to more broadband circuits, the bigger challenge we've seen with WAN optimization in the last 5 years, let's say, isn't things like deduplication. How do I make a 5 megabit or 2 megabit or 1 megabit MPLS link look like a 3 or 5 or 10? How do I actually get, our customers are challenged to get full utilization of the bandwidth they've got, right? They go and put in a 100 megabit broadband connection, and the source of that's North America, and they're going to a user set or an application set that's in Australia. So the distance of that requires TCP/IP optimization. We need to spoof the acknowledgements so that we can get the data on the line. And so I think that's where we really see a big use for WAN optimization today. And I think when you get to very old, the more less developed markets, and there's still a lot of them. You mentioned also the Cisco putting the SD-WAN code onto the ISRs. I mean, one of the big reasons for ISRs is because there's still a lot of copper out there, and all I can get to T1. So in those environments, I still need the old school WAN op stuff, because all I have is a T1 to my manufacturing site or to my distribution site or whatever in some third world country. I think wireless is going to change that too, right? So as we, wireless is kind of bypassing copper and giving us broader band pipes on a much broader scale.
Your take on how encryption and the pervasive nature of encryption, almost all the application layer streams are encrypted nowadays. How's that impacting this?
Well, I think the encryption, I'm not sure the root of the cause, or I'm sorry, the root of the question, right? So.
Okay, so you go back to WAN op. I mean, unless you're a man in the middle and have the ability to decrypt, accelerate, re-encrypt, and then do the same thing on the other end, you can't really get into WAN op too much, or you can only add limited value.
Sure, right. Well, I think so. That's again, that's a great use case for communication hubs, right? Because if I need to be able to break traffic out, midpoint, right? And there's I can use a communication hub and a decryption advice. If I'm running a Apcela platform or a VeloCloud platform, I can put a VeloCloud node in middle mile points, and so I can have access to those data streams at those points. I think the encryption is powerful beyond the WAN op, because it allows us. It takes away some of the reasons we've been so stuck to MPLS. Right. I feel like the MPLS is a secure environment, whereas now the SD-WAN can give me a very secure environment on a much flatter network and better cost, more cost-effective network.
Okay, I don't see any more questions that have come in from the audience. Now, Mark, I noticed on your closing slide here, you've got a survey and a T-shirt offer. Can you comment on that?
Yeah, you bet. So, pretty simple as that. It's a free T-shirt. I think there's a survey that might take 2 or 3 minutes to bang through, and then free if you like the Apcela logo. Of course, the Apcela logo is going to be on that T-shirt. But a nice black and red T-shirt for the new year.
Okay. Thanks a lot for joining us, Mark. This has been good. I don't see any final questions. Drew, anything final from you before we let Mark go?
No, and it looks like, Mark, also on your slide here, you've got some links for additional resources if people want to get more information.
Yeah, you bet. So, saw you guys just did and I think you mentioned as well, Ethan. So for folks that are kind of at the SD-WAN 101 level, I think that podcast is a great piece of information. Gartner, within the last couple of months, released a compilation. So for folks that are Gartner clients, if you're a Gartner client, back in October, they released this piece of research, which is a compilation of basically their last 12 to 18 months of SD-WAN research. So it's kind of all in one place. And then on the Microsoft front, there's really 2 sets of resources, those that are aimed at what we'll call the data services, Exchange and SharePoint, and then those that are aimed at the voice services and how do I get Skype for Business online, evolving to Teams. How do I get that performing the way I want? And I think one of the big things people struggle with is the multicast video capabilities in there. And again, what tends to get in the way is the internet. 9 times out of 10, we're finding the problem is I'm not peering effectively with Microsoft. I'm pushing too much of my traffic to the public internet, and I'm wondering why I'm getting variable performance. And that's why. It's because I'm using the internet to send video broadcasts around the world. If I could just put that stuff on the Microsoft network or on more of a private network, I'd get better performance. So those are resources that can kind of help you figure that stuff out.